Previously, we learned about capacitors in combination. When we combine three capacitors, call them C1, C2, C3 in parallel, we actually make bigger capacitors. This is 1 farad plus 1 farad plus 1 farad. You got 3 farads. In series, it's different. 1 over the C equivalent, that's the total capacitance, is 1 over C1 plus 1 over C2 plus 1 over C3. So if we have 3 1 farads, here's 1 plus 1 plus 1 is 3. So 1 over C total is 3. The total capacitance becomes 1 over 3, 0.33. That's smaller than each of the 1 farad capacitance. So this is for capacitor. For voltage, for any devices that are connected in parallel, their voltage values are all the same. So here's the case for the capacitors. And here for any devices connected in series, the total voltage is always the sum of individual values. So is that for the capacitors. So this is how the total voltage values are. Well, that's capacitor. What if we have resistors? For example, so these two are circuit diagrams, and these are picture diagrams. If we have series circuits, like these two that represent the same circuit, if we have 2 light bulbs connected in series, 2 light bulbs connected in parallel, what's the total resistance gonna be? Well, so this is part 2. We have just reviewed the capacitance, voltage, and charge after combining the simple ones. That's series combination and parallel combination. What we're going to introduce new here in this slideshow is how the resistance, voltage, and current changes when you combine resistors in series and parallel combinations. In the end, we're going to compare the combination for capacitance and resistance and see how different the rules are. Let's see, we have resistors in series. In this example, we have 3 resistors, R1, R2, and R3. Excuse me. The resistance becomes larger. So the current after passing through R1 has to go through R2. And after going through R2 has to go through R3. It has to push through all 3 resistors. So you're making a larger resistor. For the general rule of series combination, here voltage is always the sum of individual values. And in the circuit of series connection, the current that flows through R1 has to go through R2. And that flows through R2 has to go through R3. So the current is the same through R1, R2, and R3. That was the resistors in series. And here resistors in parallel. For resistors in parallel, they combine by the inverse rule for resistance. And in parallel, they always have the same voltage. For any devices that are combined in parallel, they always have the same voltage. Current will add up. The current that goes through each branch, each of the 2 branches, so the 2 current values will add up to be the total current that goes out of this combination. So this is new resistors in parallel. So the last part is we're gonna compare the combination of resistors and capacitors to see the difference. We see for series combination, the resistors will add up directly. The capacitors will go by the inverse rule. Well, for parallel, it's the opposite. So this is for your reference. In summary, this is what we learned. First, we reviewed the capacitance, voltage, and charge for series and parallel combinations of capacitors. And we introduced, this is new, the resistance, voltage, and current for series and parallel combination of resistors. And in the end, we compare the different rules for combining capacitance and resistance.